Thanks, Ari. My name is Pascal Joly, and I'm the Director of Business Development at Quali. I've been at Quali for a few years now and leaping around different roles. So the picture you see here is actually when I was a product manager and doing a presentation at one of the previous Swamp Up events. So many of you might have not heard about Quali, so I'll just give you a brief snapshot. We're a software company, and we're all about enabling innovation through automation of application environments across any cloud. We have a wide variety of customers, mostly enterprise in a pretty wide range of verticals. And another thing is that we've been partnering with JFrog for quite a number of years now around our DevOps use case. In this presentation, we're going to talk a lot about the environment, and I just want to get level set on the definition. So typically, when people think about an environment for an application, you will think about infrastructure, and more particularly cloud infrastructure. So think about what you would want to deploy as a CloudFormation template in AWS, ARM template in Azure, or even some types of Terraform template as infrastructure as code, and it could be also Kubernetes services. But the way we view it is broader than that. And environment in the context of environment as a service is the inclusion of also application and data. An application means could be any number of marketplace applications available already for your public cloud, as well as PaaS and cloud services, or custom applications, and that's when you retrieve those custom applications built from an artifact repository, such as JFrog Artifactory, for those of you who are familiar with it. And then we have also the data components that is part of the environment as well. So in the context of DevOps, many of you are familiar already with the figure 8 describing the seamless transition between Dev and Ops. When you think about the need for environments, they are really used at every single phase of this cycle, of this life cycle. So from the development phase to the build phase, to the test phase, moving on to release and deploy and operation, you need environments at every single stage of this life cycle. So as it seems very simple, when you look at it from this slideware standpoint, it is actually very difficult to implement in reality. And what we're facing first is sort of a cultural challenge, an organizational challenge. It's essentially different people, different teams that have not been used to cooperate in the past and collaborate now need to work together. And if I start from the right-hand side, we have the IT admin operation manager persona, whose role is to control the expenses related to cloud resources, very often responsible for allocating those resources to others in the organization, as well as responsible for any security issue and compliance. So that's what their goal is. And if you look at the other end of the spectrum, the developer, QA engineer, they're responsible for releasing an application, and they're under a lot of pressure to release an application as fast as possible. And they have some ability to spin up resources in the cloud using a variety of open source infrastructure as code tools. but they don't necessarily like to go through all the process of requesting resources, and they might even use just static resources if need be. And then in the middle, we have the DevOps lead, who's been tasked to automate a wide variety of tools and making them work together to provide an end-to-end automation solution and service the entire organization with that. So if Mark is back online, I'll let him also add a little bit of color to this.
Yeah, can you guys hear me this time?
Yeah.
Okay, good. Just real quick, I'm Mark. I do apologize for my connection issues. That is the joys we're all experiencing these days. So I think Pascal summarized it pretty well, but I think when we think about the developer in particular, right, they have to be able to work in an environment that they control, that has kind of their special tools in it. It's not the same as a production environment, but it also often has a much greater rate of change. Different developers and different developer teams require different things. And this often brings them into conflict with the other teams who want to have, very production-like environments all the time, very uniform, the same thing every time. And so this kind of tension, right? Whereas on the other hand, when you start getting in later in towards the value chain around tooling, right, that consistency is critical in order to deliver high-quality operating software. And this is the basic tension that underlies DevOps. And I'll leave it there.
Thanks, Mark. So what ends up happening is really two different streams of process. One of them is the formal official stream where a developer submits an approval for an environment, and then the IT team is going to vet it and then allocate some resources, either in the private cloud or the public cloud or whatever their quotas are dictating them to use. And then they will eventually give them to the developer teams. Very often do not want to wait, and they don't have the patience for that, so they will end up bypassing the process and using their own shadow IT public cloud resources to just get the job done. And it's obviously very detrimental for the overall organization, because eventually you end up introducing potential security risks into your application, as well as introducing discrepancies between what the application is developed on and the actual environment that will be used in production. So how do enterprises who are trying to tackle this challenge typically, what approach would they use? And one of them is really driven by the need for speed, and this is to address the need for developers to get the job done. And what the traditional approach has been to use infrastructure as code, which is really one of the core tenets of DevOps. And infrastructure as code is a lot about automation, as well as versioning of infrastructure component that you would need in order to automate any need that you would have around your environment and provision them in your cloud. And the problem with infrastructure as code is, first, they require a lot of expertise in terms of, depending on what infrastructure as code solution you would use, whether it's particular to one cloud or whether it's particular to one technology. So you could be the next, you have to become essentially an expert in CloudFormation templates if you're using AWS, or in Terraform if you're going to use Terraform, or in any other language, maybe Kubernetes if you're going to use Kubernetes. And as a result, you are burdening this, or first you end up burdening the developer who's really in charge of developing an application, not trying to figure out a different template, or relying on expert knowledge to do that. And expert knowledge, as we know, they come and go, and they're not, it's not scalable. And so the other problem with infrastructure as code is you're essentially giving the keys of the cloud to the developers, and the operation team ends up releasing control. And that's bad, as you know, because we're concerned about the entire organization is impacted due to the lack of cost control as well as security. So this is not the perfect solution as is right now. The other aspect of the other approach that enterprises have been taking is to try to emphasize the control part. And the traditional way to do that is to use a cloud management platform. Cloud management platforms are great to offer the governance around the allocation of infrastructure, cloud infrastructure resources. Eventually, they usually have this self-service portal where different pieces of different environment can be offered to the end users, which are going to be maybe your developers. The problem with the cloud management platform is that they don't necessarily integrate very well with the value stream of DevOps. And there's a lot of work that's needed in order to manage it in a pipeline, completely automated mindset. And the second aspect is that they still have put the burden of creating all this self-service infrastructure to the ops team, and as such, a request for a new type of infrastructure has to be made by a developer, and essentially you are not able to achieve the speed that you want to have your DevOps goals met. So that's why we introduced this concept of environment as a service, which is essentially combining the best of both worlds. So we want to have control and we want to have speed, and how can we make it work so that we achieve both? And one of the way you can achieve that is first by making all these three different personas that we talked about at the beginning of the presentation work seamlessly together towards a common business goal. And that means offering to the IT admin the control that they need, offering the DevOps lead the tools that they need and the integration that they need to provide a service to the developers and the QA engineers who have the environment that they need when they need them. And so having a standard platform that can achieve all these is going to be critical. Now I'm going to let Mark actually dive in a bit more into this collaboration aspect.
Yeah. So it's actually something that, in some ways, JFrog kind of discovered over the years working with our customers. And that is that the different people have in common, the dev QA engineer, the what we now call the DevOps leads, the IT admin ops guys, what they have in common is the software binaries, right? The IT admin ops guys, they don't really want to worry about how to compile the source code, or, they certainly don't want to be recompiling it all the time. The dev engineers, their final output is those binaries, and as it goes through the automation process, what actually is ushered through the automation process after the first few steps is the binaries themselves, right? A developer pushes to a Git repository, then the Git repository triggers a CI build, and the CI build pushes out to a binary repository like Artifactory, which is then shares out its binaries to all the different environments, to the developer in their environment, to the automation environments and the test environments, and to the final operation IT environments that are being run. And we really, if you have a common source of those binaries, then everybody automatically, naturally starts talking to each other. And it kind of then lends them to ask the question, okay, this is the source of the binaries. How do I know more about the binaries? And so generally speaking, somewhere near the binaries in your artifact management, you want some sort of bill of materials. What Git commits did the developer do? What dependencies were pulled down during the build? One of the things about dependencies is when you have transient dependencies and dependency tree changes and you have security patches happening all the time, the only time you can know for sure exactly what dependencies were used during the build is during the build itself. Environment variables can impact a build. I personally have an experience of trying to reproduce a build 6 months later and really struggling and then realizing that there was an environment variable that had to be set. Fundamentally speaking, you want to know who built it, when was it built, where was it built, why was it built? And if you have that information and you store it with the binary, then all three roles have a traceability. So if IT has a problem, they know what developer to go contact to ask to fix a given commit. And the developer doesn't spend a whole lot of time working with the automation team trying to figure out what binary is really there. All of those questions are clearly defined because you all pulled from a single source of truth, and that source of truth contains the metadata you need to store the data. And then additionally, when you have a source of truth like that, you also get to ask another question, which is it safe? When you do the component analysis of the binary, right? So every binary that you're sharing, and binaries could be Docker containers, they could be jar files, they could be Python eggs, whatever it is, you want to look at that and find out, today software is 90% open source. And so you want to go in and find out those open source components. First of all, of course, you have some license questions, but also this will let you know about known security vulnerabilities that may exist and decide, is it safe for the environment that you're trying to send it to? And this is the first step in a larger security process that I'm going to let Pascal talk about for the environment as a whole.
Thanks, Mark. So how do we put all this together? And here, this is really trying to make something that very often could work at the team level, at the developer level, make it work for the entire enterprise. And the idea is to have a standard set of tools that enable you to allocate resources to every single application team, and then provide from the operation standpoint the governance and policies that you require to properly enable those teams to do their job. And each team typically would be comprised of a DevOps person who might be across different teams depending on the size of the organization, and a set of engineers working on an application or even a subset of an application. If you're talking about a web scale application, it could be just an application service. But they have different needs, and they would want to get what their environment at the right time without having to worry about the cost aspects and without having to worry about the security aspect, which is really the responsibility of the IT administrator. And so if you have everybody working towards this common business objective, which is to release the application as fast as possible with the best quality and within the boundaries of security and cost, then you can achieve actually your goals. So now let's dig in a little bit into what does it mean to blueprint a system that can be reusable by many different teams. And here we're talking about actually something that's quite complex. If you think about all the components that are needed to enable infrastructure plus an application environment, a complete application and infrastructure environment on demand, there are a lot of details that come in place in terms of the boilerplate of providing DNS, providing the security rules, the firewall rules, the storage information, having the ability to deploy your artifact and do health check on top of it, do security check on top of it. All this is really the core of the work that you don't want to have to repeat every single time. What you worry about is the tip of the iceberg, which is really the application. And the rest of it, what you want to do is modularize it and highly automate it so that you don't have to worry about it each time you have to recreate those environments. And that really simplifies the job of the DevOps person or the application architect who's typically in charge of defining those blueprints. So if you look at it in the context of the entire life cycle that we call value stream, it's not just one or two components. It's an ecosystem of tools, and in environments have different ties to different components at every single stage of this value stream. And typically, you will start with a pipeline tool like a JFrog pipeline, who will instantiate those environments. And then you will have also a repository. Your blueprints will be in source control. That will be enabled to be, and I'll demo that in a minute. And then the application build will be pulled from your artifact repository, such as Artifactory. And then once you move to production, you might have a different set of environments with a different set of requirements for those environments. So I'll let Mark describe a bit more some of these concepts. Mark?
Thanks, Pascal. So as Pascal said, what you see is different environments. And the different environments reflect different stages, effectively, in the life cycle of your software. And so as the software is moving from one to the other, you may need to do restrictions, right? So, for example, you don't want it to be the case that a production environment has easy access to developer class artifacts that aren't tested, aren't ready to go, aren't security checked. And so in Artifactory, we provide a solution for this, which is repository promotion. So inside Artifactory, you have multiple repositories for each environment, and you actually move the artifacts as they pass the quality gates, as it passes the chaos monkey test, right? You move it from a staging repository to the production repository. And then the production repository only has access to production-approved artifacts. And they've been through the security scan, they've been through the testing, they're ready to go, and this adds both another level of security, it adds another level of control, but it doesn't impede the automation in any way, because the same automation that worries about, making sure that the binaries are actually tested can then promote the binaries from one repository to another inside Artifactory. And then you can basically just take an environment description and point it at a different repository in Artifactory and get the appropriate set of binaries for that environment. So next up is our demo. I think, Pascal, you already talked about cost control, right?
Yeah, I mentioned a bit about cost control. Just one touch point here is that in terms of having visibility of your consumption of resources, another aspect is that's very important, and I'll show that in the demo as well, is getting not just the specific details about every single infrastructure components that you consume, but really getting the big picture on how these costs relate to your each application development initiative. Because really what you care about is evaluating the effectiveness of your infrastructure consumption in the context of an application development effort, not just trying to reconciliate all the different elements that are commonplace when you're talking about cost of cloud infrastructure. And as you, some of you might know, it's actually quite complex to decrypt one of those dashboard or reports that you look up on a cloud provider standpoint. So that said, yeah, let's jump into the demo. Mark, do you want to go first and share your screen?
Yeah, let's hope the technology is with us better
right.
than it was before. Okay. So let's see. So this is Artifactory. And that's not quite how I wanted to start, but hopefully that will be the last of. Let's see here. I am not having a good day. Let's just take that as given. Okay, let's do this in a slightly different way. See if the rest of it's working. I've been having bad network issues all along, and I think that's part of what I'm seeing here, which is not exactly what I had in mind for my day today. So here's like a simple Docker container that we can see, and you can see other types of repositories that we have. We have Helm charts, we have NPM, and then we talked about promoting artifacts. So you have you have dev repositories, and you have repositories for the promoted libraries. And in Docker, you have dev and production repositories for Docker. This is a fairly simple, demo environment, so it doesn't have lots and lots of repositories for different environments. And we also talked about the bill of materials. And we can see JSON objects here. Let's just switch over to the build view. And we can see here data on a build, right? Here's the information of what artifacts were in the build, the environment variables. We talked about security information, right? Being able to dive in and find out what's going on with an individual artifact. Where exactly is this problem? And one of the great things about X-Ray is that it does a deep recursive scan. So you take a Docker container, and inside the Docker container, you have the different layers. And inside each layer, you can dive in deeper and see the binary. So this is an OS layer. And then in other layers, we have other OS items that were installed. And you can see where the problems came in. And if you're really curious, in some cases, not in this particular container, but in some cases, you can go in deeper. So if inside the package, there are other packages, like, for example, if you had a Java WAR file, inside that war file there might be a jar file. But you can also reverse the tree. So now we have this buster lib that has a high security vulnerability with a buffer overflow issue. And now I can see all of the containers that contain this particular version of this library. So I know all of the containers that are impacted, all of the builds that were impacted as we're moving along. And then if we want, we can look now for the next part of the demo. We have specific binaries for a fully sort of finalized tar-GZs of the binaries that are going to be deployed for our promotions application. And I will turn it over to Pascal to show you how to deploy that with Quali.
All right, thanks, Mark. I'm going to share my screen. Okay, so here what you see is when you log on to Cloud Shell Colony, which is our environment as a service platform for DevOps, you are presented with the different steps really that will take you through deploying your application and providing a full environment for this promotion manager application. So here we're part of a team that's developing a container-based application on Kubernetes, and we want to deploy it using Azure AKS. So one of the first steps that you would do is to add a cloud account, which was already completed, and add your repository. So one of the repositories that you're going to add is a repository for your blueprint, which will be here stored on GitHub. And all these will be version control on GitHub. And then you define your cloud accounts. So here we have a variety of cloud accounts associated with that space, Azure, AWS, and we support as well Google Cloud. And you define your users, which is really a roles-based access control for your space. And here you would have users that are defined more as end users versus users that are defined as your blueprint administrator who are going to define the blueprint. And finally, defining your ecosystem. So here we've added an Artifactory server, the one that Mark just showed you a minute ago, to Cloud Shell Colony, and it's really just a matter of providing the server URL and then your user logon and API key. It's a very, very simple process. And once you're done with it, you're ready to work on your blueprint. So here I have a number of blueprints that have been defined for my promotion manager application. And all these are automatically synchronized from my GitHub repository. And we're going to deploy the blueprint, this version of blueprint that's going to be implemented using Kubernetes on Azure. So here you can see very simply that this blueprint has three different components: MongoDB database, a promotion manager API service component, and a promotion manager web UI. And as well, you can see everything is defined in YAML. Everything very, very simple YAML file. And once you have done that, then you can actually start publishing this application and consuming it first in a sandbox environment. So let's say that we want to test this application and and we want to run a number of testing on this. So we're going to create a sandbox. So this is pre-production. And here, all I have to select is my promotion manager application. So this is the one that we're going to use on AKS. And then just select some parameters. So here, we're just going to use the name as promotion manager. And then we have our default parameters that are already pre-selected. So these are the artifacts that I'm going to pull out from Artifactory for my different application components, for the web server, the API service components, and the MongoDB application. So I have also a data set. And this is the duration, the default duration that's really specified here as part of my policy, so that you don't consume your resources automatically. This sandbox, since it's pre-production, will be destroyed after here 2 hours time window. So here, I'm going to just launch the sandbox. And now that this sandbox is being launched, we can see the different phases of the sandbox application, the sandbox deployment. So the first part is you're creating the infrastructure, so deploying the different instances in the cloud. And then you're going to prepare the artifact, essentially download them or retrieve them from Artifactory. And then you're going to deploy the application. So here we can see that some of the steps are already being completed. And you're going to deploy the application using whatever script that you want to have to install your build on your different components. And making sure then finally that your environment is properly up and running, so running a number of health checks to verify that it's working. So of course I'm showing this in an interactive manner, but whoever is deploying this sandbox, which would be maybe your application tester, will just be notified when this sandbox is ready. And similarly, this could be done completely automated by one of the pipeline tools that I've shown that we support quite a wide variety of pipeline tools. But for instance, if you're using a JFrog pipeline, you could just trigger automatically this whole workflow from using our API. So since we don't need to wait for a few more minutes, it's going to take a few more minutes, and I don't want you to wait for this to be ready. I've deployed an environment already here that's already active. So once it's deployed, you can see, you can review the different parameters and artifacts that have been deployed here on the environment. You can have access to the endpoints, so the direct access to the web UI of this promotion manager application. And then you can review the different components from an infrastructure application standpoint here, which is really what maybe most of your developers would care about, or from an infrastructure standpoint, and this is really more if you want to connect to one of those components maybe for debugging. So another thing that I'd like to show you is this cost analysis, because this is an important part of the value proposition of environment as a service. And here we're changing hats and looking at an IT administrator who wants to have visibility on the entire consumption of this particular team, and even across different teams. So here I see that I've been using different types of cloud infrastructure over the last month, and one of them has been going down, another one has been going up. I got my forecast towards my budget on what, if I continue like that, what will be the total spent for this month. But what's more interesting to me is really getting the cost breakdown by activity, which is really what type of application testing I've been doing for performance, security, and even production. And I haven't talked about production, but this is yet another component, of course, of this the platform is you want to have standardized environment all the way to production. So here, for instance, I'm seeing that my environment for production in the US costs me $11, but my forecast is $300, and it's using those types of cloud. So it gives me really a picture that's business-driven of my entire application infrastructure consumption. And just final word before we continue to wrap up. The production environment here is defined obviously with a separate repository, as Mark touched on, and I have the ability to upgrade that environment using the similar, using a pipeline tool, and out of the box we offer blueprint deployment, which means I can gradually deploy part of my environment when I want to upgrade to a new release. So that's all I have to touch on for that demo, and I'm going to stop sharing and we'll go back to our presentation. So now that we want to wrap up, I think it's important to recap on the different the benefits that our combined solution offers. And one of them is really scale, so providing an enterprise level solution that can be standardized across multiple teams, thousands of users, and we already have both large, really large enterprise customers that do not want to have 50 different solutions across the board. So it's very important to be able to scale across an entire organization and being able to collaborate and effectively enable collaboration across those different teams. So Mark, I'll let you touch on the security aspect.
Yeah. So security is an end-to-end activity, right? This is why some people talk about DevSecOps. You've got component analysis and various tools that are applied way back at the developer end of the chain. But you also have to worry about, you can put the most secure piece of software out there, and if you, make the root password, people will still hack your machine, right? So by combining the concepts that we have here of a DevOps platform that gives you insight into the security aspects of the binaries with a environment as a service platform that allows you to easily and repeatedly deploy secure environments, you end up with a much more secure solution end-to-end at all the different levels and environments that you need. And now, Pascal, you want to talk about cost?
Sure. So we touched on the governance and the fact that you want to control the allocation of infrastructure resources across the different teams, and this is really an ops requirement. But here we're also talking about the usage of dynamic environments. As long as you are not in production, there's no reason to keep your test environment or your dev environment up and running all the time when you don't need it. So this is a very important piece of the solution, is the ability to automatically destroy and remove all the unnecessary services and environments that's no longer needed, and maximize the efficiency of cloud resources, no matter what you're using, whether it's Kubernetes service or storage services. This is really key to managing your costs for your entire DevOps lifecycle. Mark, you want to take on the last one?
And the last of these is speed. This is the major benefit of automation in general, right? Automation is the heart of DevOps, and the main reason we do it is to get speed. You need to have self-service environments You need to have an end-to-end DevOps platform. You need to be automating every step of the way, and you need to have tools that allow you to automate every step of the way, right? If you don't have the right tools, you're just going to get slowed down by things that shouldn't be slowing you down. And as soon as you start letting your speed of development slow, you're letting your competition get an edge on you. And that's really what it comes down to in the entire story of DevOps, is you must release fast or somebody else will. And then, you lose business.
All right. Thanks, Mark. And if you want to learn more about Cloud Shell Colony, feel free to visit our website. And I know there are also some additional resources that you can consult for the JFrog products. So I think we're ready to wrap it up with Q&A.
Yeah, I think we're ready for questions. So, Nara, I see a question. You want to read it out for us? Looks like maybe we lost Nara, so I'll read the question. It looks like this one is for Pascal. Does your environment as a service solution include cloud infrastructure, or are you using an existing cloud that a company is already deployed on and already using?
Yes, that's a good question. There are a number of solutions out there that try to provide you the infrastructure as well, but we actually would prefer for you to decide what cloud you want to use. And so we're cloud agnostic. We support quite a variety of the leading cloud provider, as well as Kubernetes solution. And you can really define what you do, what you use in the backend. And we do the rest, and we do the automation of those infrastructure.
Cool.
I guess we have another question, right, Mark?
Yeah, it looks like there's at least one more. And everybody, if you have additional questions, please just fill them in the Q&A tab, and we'll try to get to them. So the second question looks like it's directed at both of us. Do customers use your platform in a more interactive way or using API calls? So certainly for JFrog, I can speak that, while I showed you most things through the UI, we know that 99% of use of your typical JFrog platform is done fairly strictly via the API when it comes to your basic artifact management. When you're getting into some of the security features and some of those things, people may be more inclined to look in the UI, but even there, most of the time they're responding through the API and getting data into a build or some sort of automated process that they then handle. Pascal, how does it work for users with Cloud?
Yeah, so for us, we're seeing a wide variety of usage, and depending on the maturity of the customer, they might be more comfortable initially with the interactive mode and the sort of the self-service approach, which already provides them a lot of value. And then some other teams, maybe within even the same organization, will do everything automated because they already moved on to an API way of driving everything from the pipeline to and from just a new merge to master of a new version of the application. So we're seeing things quite distributed across the board.
Okay. I was going to say, it doesn't look like we have any more questions, Nara, so you have any closing business?
No, those are the questions that we got. So I want to thank Mark and Pascal for this great presentation. We hope you enjoyed it. So this webinar was recorded, and you will receive the recording within 24 hours. I hope you were able to check out all the links in the resources list. If you have any additional questions, you can reach out to us at webinars@jfrog.com. Thank you, everyone. That is it from us, and we hope to hear from you soon. Thank you.
Thanks.